Right, so one section of an audio system uses a bandpass filter to limit the frequencies applied to a mid-range loudspeaker. The output of the amplifier driving the loudspeaker delivers a sinusoidal output with an RMS voltage of 10 volts, which is going back to power supplies. So hopefully, to work out the peak value, you should have multiplied the RMS value by the square root of 2, giving you precisely 14.14 volts. And then we go on to the filter question. It uses a 60 millihenry inductor, a 0.33 microfarad capacitor. So using F equals 1 over 2 pi square root LC. Putting the numbers in, you should get 1062 hertz. And then the reactance of the inductor, we're going to use XL equals 2 pi FL, giving you 454 ohms. Right. Turn it over. Now to work out the RMS value of V out at the resonant frequency. To do that, first of all, we need to find the dynamic resistance using this equation here, and that gives us 8242 ohms. And then we're going to use the potential divider formula with RD as R2, so that goes at the top, and then adding the resistor value to the bottom there as R1, and that gives you 9.24 volts. And now to calculate the Q factor from the datasheet, Q equals 2 pi FL over RL. So we're using the resonant frequency as F, L being the value of the inductor, and then 25 being the resistance RL of the inductor. And that gives the Q factor of 18.14. No units. And then we've got the bandwidth formula. We can rearrange that to bandwidth equals resonant frequency divided by Q. So we're getting the resonant frequency again there, 1062 divided by 18.14 gives us 58.5 hertz. Now, to sketch the graph, we've got the resonant. You can either do this showing the resonant frequency in the middle there, like that, labelled, and the bandwidth split in two on either side, but they seem to accept it fine if you show the width as the bandwidth there, and then label that frequency hertz there, and you've got to label the voltages. So there's the 6.48, that's 0.7 times the peak value, which was 9.24 volts, like so. Notice it's not really to scale on the x-axis, but it doesn't seem to matter. So let me get the right shape and label the bandwidth. And then we've got the voltage. When the filter is connected to the speaker system, the resonant frequency is affected by the impedance of the speakers. To correct this, a buffer is connected to the output of the filter. And that's the voltage follower circuit, where we've got the high input impedance of the op-amp here, and the feedback coming round there with no resistance there, giving a gain of 1, but with high input impedance and low output impedance. And that high input impedance means that the filter is not being loaded, i.e. there's no current flowing out of it, so therefore its resonant quality factor and resonant frequency aren't affected. And that is that.